Okay, so on Canvas for today, there are several different videos that are on different lab techniques. Okay, and the reason that we are starting this is because kind of starting Friday and really going into next week, we're going to be starting to talk about the IA, which is called the internal assessment. And as it says on here, the IA, it's part of your IB grade, along with the scores that you make on your test that you take at the end of the year in May. And so for science classes in IB, what the IA consists of is it's called an independent investigation. And basically, what that means is that you are going to come up with your own research question that's based on sort of your own a topic that you're going to choose. So it has to be something that obviously you can relate to chemistry because you will be using techniques or lab techniques that we kind of have learned about, but you get to pick kind of the topic to start off with, and you get to choose, to how to investigate it. And so what you'll do is you'll come up with, and we'll start going through this on Friday and next week in more detail because I have some things to help guide you. But essentially, you're going to come up with sort of a broad topic and then form a research question. So, your research question could be like, how does this affect this, or how does this change this, and obviously you'd be more specific with what you're going to be testing, but your research question is going to be something similar to that format. And then if it is something that is that I say I approve and I say like, yeah, that's something that you could do, then you will start to develop a lab investigation. So you'll do some background research. So that's kind of part of what we're doing today is we're learning some of the background research on some of the different lab techniques. And you may have to do more specific background research on your specific things that you choose to have in your lab. So if you choose to do something that involves, a titration with acids and bases, then maybe you have to do some research on specific substances or specific acids and bases. Or if you choose to do something with calorimetry, maybe you have to do some specific background information research for the substances that you're going to use in your calorimetry lab and sort of how their reactions would work. So you kind of do your background research, you start to put together like a procedure, and you're going to develop your own like lab investigation. Now, there are options to do this online. However, as I'm going to get into more on Friday and next week, the online options are probably like 100 times harder than doing an actual lab investigation like in the lab, because the level of expectation that they have if you choose to do something that is virtual, it's like way higher. You have to have like multiple databases that you pull information from to compare. You have to have like several different, if you do like a simulation, you have to have several different variations of things. And so while there is an option for virtual, I'm going to talk more about this Friday next class, but I'm going to highly encourage you guys to come in person to do your lab. Obviously, if you are not comfortable, you don't want to come in person, that's your choice. And there are options that we're going to talk about for doing something virtual. But just know that like my recommendation to you would be to come in person to do this part of our class that we're going to be working on for the next few weeks. And we have actually gotten permission for you guys to come in person, even if you're still a virtual student. We have gotten permission for you guys to come up when you need to. If you need to come up to use equipment or to use chemicals or just to be in the lab and get things set up and collect data. And so you're allowed to come, not just like during our class period, but you could come up, on an entire B day, and you could just, or an A day, really, you could come on any day. And you would sit in my classroom and you would work independently on, whatever you needed to set up to collect data for that day. And if you needed to go to your synchronous classes in between, you could just do that on, your computer here in my room. But because I did have a senior who was doing this, and she came sort of at the end of December after this was approved, and then she also came a few weeks ago, and so she came and basically kind of sat in here most of the day. She was already an in-person student, so she did go to some of her classes during some of the class periods. So it's very flexible. So you can come up and you can stay for an entire day if you want to. to collect data, which is highly beneficial because at the beginning, some of these things are going to take you guys longer to figure out how to set up. It's kind of like trial and error because it's the first time you've really done it. And then once you get things going, then it gets a little bit easier. But it's good to have a good chunk of time like that where you can have time to set everything up. You know, if there's any issues, then you'll be aware of it and you can kind of correct it before you get too far into it. And then you'll actually be performing your experiment. You'll actually collect data. So you'll have to make sure you're writing down data. And then once you're done collecting your data in the lab, that's it. You don't have to come back. So you only have to come in person long enough to like set up whatever equipment and chemicals you need to do and then collect all of your data. Okay. So it's not like you're going to be up here for like, you know, every day for an entire month or something like that. Like for example, the student who, my senior student who was working on it, I think she was up here for like 2 days back in December before we had left for winter break. And then she was up here for 2 days in January, or maybe 2.5, because she was going to her classes on some of the days. So she needed a little extra time, a little extra half day. So, you know, I'm not talking about you need to come up here, you know, for 2 entire weeks or 3 entire weeks or something like that. Just maybe 2, 3, 4 days. It really is just depends on what you choose to do. It depends on how prepared you are and how easy or how difficult it is for you to get equipment set up and get chemicals ready, and then how you get everything set up and collect your data. But once you have all the data collected, then you're done with the in-person part of it. And the rest of it is doing the data analysis. So that would be like doing calculations, making graphs, and all of that stuff you can do at home on your computer digitally. Doing the error analysis to determine, you know, do you have any percent error? And because most likely you will. And then doing that analysis of, well, what could you improve? So what could you change about how you had your lab set up? And so at the end of this whole thing, you're going to end up with a 6 to 12 page paper. So that's the limits. It has to be between 6 pages and 12, no more than 12. And you'll have like a works cited page because you will have in your background research, you'll have found resources that you'll have to sort of cite on your paper. So you'll have citations similar to what you would do in like an English paper. Okay. But that works cited doesn't count in the 6 to 12 pages. So between 6 to 12 pages, and you'll have everything on there from your research question to your background information research to your actual like list of equipment materials to your procedure, any data tables and data collection you'll have on there. You have to have one sample calculation. You don't have to show work for every single calculation, but you have to have like one sample of each type of calculation. Any kind of graphs of your data that show trends that you can analyze. And then you'll have a section towards the end where you will discuss your results. You'll discuss if you had any errors and maybe how you could improve upon it. So what we're going to be doing for today and Friday is I'm going to have you guys look at some lab techniques that could be something you would choose to kind of base or like start your investigation off of. And so there are several different videos on here and I kind of have them separated into sections based on sort of what topic they go with. And so what I want you guys to do for today and Wednesday is I want you to watch them and I want you to make sure you're taking notes because I want you to pay attention to like what equipment do they use? Okay. What chemicals are needed or what substances are needed? How is the equipment set up? So if you can draw or sketch a diagram, and in fact, in your actual write-up, whatever you choose to do, pictures, you can have pictures in it. So if you want to have a diagram of how the equipment is set up, or some people even take photographs of their experiment. If there's something involving maybe a color change that you want to indicate visually in your report, you can have that in there. What data are they collecting? So what are they actually measuring? And then how is it analyzed? So what calculations do they have to do? And then how do they address systematic errors? So how are they addressing errors and how do they talk about, you know, how the experiment might be improved if you have issues at the end of it? So pay attention to all those things. Obviously there's more than that, but those are kind of the big highlights that you should really be paying attention to as you go through this, because these are the things that are going to help you when you're developing your own, because you're going to have to know what equipment you need. Like I'm not going to tell you, you're going to tell me oh, I'm going to use, this many beakers, and I need a thermometer, and I need a balance, and I need, yeah, whatever, a burette. Okay. You're going to tell me what equipment you need. And as long as we have it here at school, I'll be like, yeah, we have that. You can do that. Okay. You're going to tell me what chemicals you would like to use. Now, obviously, we have limitations on chemicals that we have here at school. So if you come to me with an idea and you say, hey, I'm thinking I want to do this, and here are the things I would probably need, I will check in our storeroom, and if we have it and it's not something, like real dangerous, then I will most likely approve it. If it's something that we don't have access here at school to, then I'll be say, hey, you might need to rethink it. You can, go back and maybe we have this, you can substitute this chemical instead of that one or something like that. I'll help you kind of work through that part at the beginning. You will have to talk about in your write up how you're setting up the equipment and how you're collecting data. So having a description of it, but also having diagrams and photos helps with that. You will have to collect data. So you will have to design your own data tables. You will have to label them, make sure that you have like your units and your uncertainties. So you'll have to make sure you have that set up correctly. You will have to do calculations. So based on whichever one you do, so they all have different calculations that you would have to do to process the data and analyze it. So just depending on what you choose, you will have to do all the calculations on your own. However, on your actual write-up, you only have to show an example of each calculation. So the reason I'm saying that is because when we talk about your IAs, I'm going to tell you that you're going to have to do like 5 different variables or 5 different variations of something. And each one of them you have to do 3 times because you have to get an average for the data. So anything you do, you're going to be doing it 15 times. So that's why this takes so long, is because you're having to collect a lot of data, because that's how science works. The more data we collect, the more accurate or precise our uh, answers are, or our analysis is, our data. And so you'll only show work for like one calculation, but you will have to do, the same calculation for all your variables. Okay. And you will have to, if there's a known value, you'll have to calculate percent error. And then you'll have to talk about systematic errors and compare like your uncertainties to the error that you get at the end after all your calculations. And talk about, well, did you have systematic error? Because most likely you will. And then you'll have to talk about, well, what could you go back into your procedure, into your setup, your design, and is there anything that you could do to fix what your setup is or what's wrong with your setup that's causing you to have more error. So the way that I have them separated, the first section is all about calorimetry, which is what we kind of just currently started working on the last couple of weeks. So this first video, it's an example of food calorimetry, which is where you would do combustion. And so this is where they will take different food sources and they will burn them, and then they will measure the temperature change of water and then use that to calculate the enthalpy, the amount of energy that's transferred from the piece of food. And so you could do something like this. This one's a little tougher to do because when you pick an experiment, you want to pick something where you can have quantitative data, because you want to be able to make a graph with an x-axis and a y-axis. And so something like this is not as good for data because you're going to be measuring the temperature change. So you will have, quantitative data in terms of you'll have a temperature change and you'll be able to calculate the enthalpy. But as far as your independent variable, which is like what you are changing, there's not a great way to do a numerical value here. Because a lot of times people will just do, oh, I'm going to do different brands of chips, or I'm going to do different types of foods, which you can do, but comparisons like that are not going to give you as good of data, or at least the type of data that like IB would want to see you do in your experiment. So if you can figure out something quantitative that you could change about your foods, then that could be a possibility. And this is one that some people have done in the past. You can also do the neutralization, which is where you mix an acid and a base. So this one is going to show you an example of using an acid and a base reaction and measuring the temperature change there to calculate the enthalpy of neutralization. And then the third video goes specifically into like the calculations that you would do for a calorimetry experiment, okay, based on the data you would collect. The second set here is something that we did last semester, which is titrations. So this first video goes through kind of a basic setup of what would you do in an acid-base titration experiment. So what are the different things you would use, the equipment, the chemicals, how would it be set up, how would you do the process? And so it kind of goes through all that. The second video goes through more of the data processing. So like after you gather your data, what calculations would you do, and then how would you analyze that data? So calorimetry and titrations are both things that we've kind of covered, and their possibilities. I've had students that have done both of these techniques in the past to test things. I had somebody last year who they did a titration and they tested different concentrations of vinegars. They got different vinegars from the store, like they got like white wine vinegar and regular distilled vinegar and apple cider. They got different types of vinegars, and they used titration to kind of back titrate and calculate and figure out the concentration of the acid that's in the vinegars. So that was something that somebody did. The last section is something we have not gotten to yet. This is from the beginning of topic 6. And so we're going to try to do this kind of as we're going through the IA, because we're getting to where we're in crunch time and we're running out of time to do stuff. But basically topic 6 has to do with rates of reaction and how fast or slow reactions take place. And so these two videos are going to go through the different types, because there's a lot of different ways that you can measure the rate of reaction. And there's a lot of things that affect the rate of reaction. So the first video is going to go through some different basic setups, because you could set up, if you're doing a reaction that's producing a gas, you could do a setup like this picture here on the left, where you have it set up to collect the gas in a closed container and measure the pressure or the volume of the gas. You can do something like this, where you have your reaction on a balance and you're watching the change in mass on the balance. Or there's one here where you're looking more for a color change and you're timing how long it takes to happen. So there's some different ways, the experimental ways you can measure rates of reaction. The second video is going to go through what are the things that could affect rate of reaction. So this would give you an idea of like what independent variable you could pick. And there are things like concentration, like the molarity, that affects how fast or slow a reaction happens at. The temperature, doing something at warmer or cooler temperatures affects how fast the reaction happens. And there are a couple other that's going to mention as well. So all three of these techniques are things that I've had students in the past use as kind of their basic technique. And then your job is to make it personal to you, or to come up with your own unique idea. So like, I mentioned the one where a student tested different vinegars with an acid-base titration, because vinegars all contain acetic acid, just in different concentrations. And then they have other things, other flavorings and things in them sometimes too. I've had students test different foods on the food calorimetry. I've had people do the enthalpy with the acid base, and they've done, different acid bases, or they've chosen to test something, different, depending on what you want to do. And then I've also had people that have done one of these rates of reactions experiments. They've set it up and they've collected and they've tested something to affect, or to see the effect of something on the rate of reaction, but they tie it into something like bigger scale. So, if you're testing certain chemicals, maybe you're testing the rate of reaction because you're going to relate it to something in the real world, like, the erosion of, the landforms or statues, because a lot of things are made of certain chemicals, like maybe they're made of calcium carbonate, or they're made of other chemicals. And so you could use your experiment as sort of a basis to help explain, why we see certain things, reacting in nature a certain way. So what you guys are going to do today and Friday is kind of go through these. I'm giving you today and Friday because there's a lot on here. And so, like I said, I just want you to make sure you're taking detailed notes, pay attention to, what are the things needed to do the experiment? How is it set up? What data would you have to collect? How would you analyze it? Like what calculations would you have to do? And then how would you look at errors? So what errors could there be, and all that kind of stuff. And then what we're going to do is kind of on Friday and going into next week, we're going to start specifically looking at the IA, how it has to be formatted, the different parts of it. And I'm going to have you guys start sort of brainstorming over the weekend for possible ideas for research questions and doing some background research. so that next week we can start looking at, okay, what are your ideas, and are you on the right track, or do you need to maybe go back to the drawing board and rethink something? And then also start talking about, are you going to come in and do an in-person experiment for a few days, or are you going to choose to do something virtual? In which case we'll have to talk about that, because it's a lot more involved doing the virtual option. So that's it for today. I'm gonna stop sharing.